I was helping a student before school, or at least I was attempting to, and it didn't work out. So I thought I'd do a few more derivatives of inverse functions, and maybe that would help, and maybe it wouldn't. Who knows? So this says if y equals x cubed plus 1, we're going to find the f inverse prime of 28. The derivative of the inverse of the thing we're given at x equals 28. So maybe we'll give a little bit more background. What does x cubed plus 1 look like? Something like this. And we're supposed to find the derivative of its inverse. Now, knowing what I know, and hopefully you know as well, the inverse of x cubed plus 1 has all the same x's and y's, but with inputs and outputs reversed. Now, we actually could find that inverse, but, this is the point 0, 1, and this is the point 1, 0. And I guess what it's saying is we're supposed to find the derivative of this inverse at x equals 28. No idea what the y value is. But what I know, that I hope you know by the end of this, is that's related to this point over here on x cubed plus 1, where the y value is 28. Okay? So the first thing I'm going to do is write 28 is equal to x cubed plus 1 to figure out what that x value is. And, 27 is x cubed. And so hopefully, pretty obviously, x is equal to 3. Okay? So there's the point 328, and this other one on the inverse is 28, 3. Cool. And so the other thing, and maybe you knew this already, is the derivative of the inverse at 28 is going to be equal to 1 over, let's just call this f of x for now to simplify. That's not the right notation, because we shouldn't change, but whatever. That's going to be the derivative of f at 3. And, we could do that in reverse. The derivative of f at 3 is going to be the reciprocal of the derivative of the inverse at 28. Right? Because all we're doing is switching x's and y's. Change in y over change in x is change in x over change in y. Okay. So what we can do, let's go back and get rid of this f of x, is we can actually find the derivative. So y is equal to x cubed plus 1, and y prime is equal to 3x squared at x equals, what is it, 3. Y prime is equal to 3 times 3 squared, or 21. So we can just put that down here. The derivative of the inverse at 28 is, maybe we'll write that in 2 stages, 3 times stuff squared, because that's the derivative of x cubed plus 1 at 3. And so the derivative of the inverse at 28 is 1 over 27. Which also means, maybe we'll put it on the graph here, the slope over here, the slope on the inverse graph is 1 over 27. And at the corresponding point 328, the slope is 27. I hope that helped. Ugly. Okay. Hopefully the last one is prettier. Ooh, a table of values. That should be fun. So this says f and g are inverses. And here's a bunch of stuff that we probably don't need to know. Okay. So if f and g are inverses, let's go through a couple of things. This says f of negative 3 is 5, which means g of 5 is negative 3. F and g are inverses, so inputs and outputs match, all that sort of stuff. And then it says g of negative 3, that's 4, which means f of 4 is negative 3. And notice we actually have that information twice, right? G of negative 4 is 3, And down here, f of 4 is negative 3. So that just, I guess, confirms our suspicions or whatever you want to say. And then our last ordered pair is g of 4 is equal to 2, which means f of 2 is equal to 4. Now, we don't need to do all that, but I do know that just for some people, even that, just the inputs and outputs are swapped thing with inverses are tough. Okay. So, now getting back to what we're supposed to be doing here, we're supposed to be finding f prime of 4. Oh, man. So we have f, we have g, and we have g prime. So I must have to use one of these things in g prime. But which one? Well, right here, the input to f prime is 4, so we just have to find, oh, there it is, right over here. Oh, shoot. Ooh, if I scribble, things go away. How fun. You iPad people are making fun of me, but this is a Lenovo ThinkPad. Anyways, f of 4 is negative 3, so that means that's the piece we're talking about. Okay, so f of 4 is negative 3, and f prime of 4 is going to be 1 over g prime of negative 3. And so we could be done. We won't be. F prime of 4 is going to be 1 over g prime of negative 3. Shoot, that's in the table. I meant to just write that. And it says g prime of negative 3 is negative 1/4. And so, of course, f prime of 4 is negative 4. Okay. But if you hadn't memorized all of this, what else could you do? Let's slide over here. Well, if f and g are inverses, well, we would know the definition. Ooh, I hope we know the definition. I do. If f and g are inverses, then f of g of x must equal x, and g of f of x also equals x. And I think that makes a ton of sense, because this says put an x value into g, take that y value, put it into f, and you'll get the x value you started with. Same thing on the other side, I guess, in reverse, or reverse order. So you can actually take the derivative of either one of these. You'll get the same information, that f and g have derivatives that are reciprocal. So on the left, the derivative of f is f prime of something. That something is g, which has a rate of change of g prime. The derivative of x is, the derivative of x is 1. So we're trying to find, is it f prime? I think it is. Yeah, f prime of 4. So we're trying to find f prime of 4. We'll leave f prime on the left, divide both sides by g prime of x. And then, well, this is a little bit complicated. So what we really want, maybe we can do it here. We'll do it in 2 stages. We're going to do f prime of g of something is going to be 1 over g prime of that something. And right after that, what do we want? We want a 4 right here where g currently is sitting. Hopefully that makes sense, right? F prime of 4, F prime of 4. Right now we have a g of x as the input to f prime. So we need to figure out where g has a y value of 4. And we can see that back here in the table. G has a y value of 4 at negative 3. So we can just put a negative 3 in there and a negative 3. Well, we have to do that for all the x's. So now g of 3 is negative 4, and we end up with 1 over g prime of negative 3. Which is, I guess, what I said from the beginning, way back here. You know, inverses have slopes that are reciprocals, not at the same point, or derivatives at the same point, slope at a point, whatever. Not at the same point, but at the corresponding points. Like, 4 in F and negative 3 in G. Okay. I mean, we got those numbers. Not that middle one. That's super weird. Okay. Anyways, I hope that helps.